In today's video, we'll be going through the applications of geometric series. Well, we can see our first problem says that a doctor prescribes a 300 milligram pain-reducing drug to a patient who has a chronic pain. The medical instructions read that this drug should be taken every 4 hours. After 4 hours, 60% of the original dose leaves the body. Under these conditions, the amount of drug remaining in the body at 4-hour intervals forms a geometric series. The first part of question 1 says that we can track the medicine levels in the human body using a geometric series. The question is, what is the geometric ratio and what is the A1 term? Well, let's go ahead and deal with the common ratio first. Well, we know the common ratio is how much we originally had and then how much is left, and we're going to represent that in a fraction or in decimal form. Well, we know that we have 60% that leaves the body, and we start at 100%. So 100% minus 60%, which is leaving the body every 4 hours. So we want to find the common ratio, which is 40%. 40% also equals 4 over 10, or 0.4. We're going to leave it in fraction form, so we know R equals 4 over 10. Now, the second part of this question asks, what is the A1 term? We know that our A1 term is the first term in our sequence, and in this scenario, we start out with 300, and that's going to be our A1 term. So A1 equals 300 milligrams. So that's number 1A done. B asks, how is N, the dose number, related to time in hours? Well, it says that at every 4 hours, 60% of the drug leaves the body. So for B, we can say that every 4 hours, 40% is left of the previous dosage. So that is B done. Now let's go ahead and go to C. C says how many milligrams of the drug are present in the body after 4 hours. This is just after the second dose of medicine. Well, we know that in C, what we have to do is take our original term, because if you remember, the standard form or the base equation for a geometric series is A1 times R to the power of N. So now we know that R equals 0.4 or 4 over 10. A1 equals 300, and now we need N. Well, we know that this is after 4 hours, and we know that every N, or every interval, is 4 hours as stated in the original paragraph. So we know that N equals 1, so we have 300 times 0.4 or 4 tenths to the power of 1. And this just gives us 120 milligrams. That is our answer for 1C. Well, now 1D says fill in the table below. Well, we know that every 4 hours we're losing 60% of our original, so meaning we only have 40% remaining of our last value, as we stated in letter B. Now, if we look back to C, we can see that it says we have 120 left after 4 hours. That's what we calculated. So that means at 4 hours, we have 120 milligrams left in our body. Now to find the 8th hour, we're going to multiply by N equals 2. So we have 300, let's put it right here, 300 times 0.4 to the power of 2, and that gives us a value of 48, and that's how much we have left. And now we do the same scenario, but now we have an N value of 3, so 300 times 0.4 to the power of 3. And why we're doing this is that we know that we have, this is the first interval, this is the second, and this is the third. And how we know that is, it's at 4-hour intervals. So every 4 hours is equal to 1 interval. So 1, 2, 3, because 0 to 4 is 4, 4 to 8 is 4, and 8 to 12 again is 4 hours, meaning that T in this table is equal to 1 interval. So now let's go ahead and do 300 times 0.4 to the power of 3. And that gives us a value of 19.2. Now we're going to do the same thing, 300 times 0.4 to the power of 4, and we get a value of 7.68. Now we have this ... in our next column. We're just going to assume they want our A of N equation. And our A of N equation is equal to 300, which is our A1 value. So we have A1 times R to the power of N, 300 times 0.4. And now think about it logically. Now if we have our N, let's say they give us 50 hours. 50 hours is not a multiple of 4, meaning that we don't know the exact amount of intervals we have, meaning we don't know our exact N value. So when we make this equation, we have to make it generic enough that if we're giving any t value or time value, we can easily find how many intervals or what our n value is. So we're going to do t over 4 as our n value, because that'll allow us to accurately get our value for n without having any issues. Because if they give 50, 50 over 4 is our interval. But if they give us 16, we know that 16 over 4 equals 4. And thus we used an exponent of 4 here. And that's how simple it is. So that means our answer for this last column, where it's dot, 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 is just going to be 300 times 0.4 to the power of t over 4. And if you wanted to do 20, instead of doing this equation, it'll just be exponent of 5, because 20 divided by 4 equals 5. And this equation will get you any value in the sequence. Now let's go ahead and do part E. Well, part E says, using your data spreadsheet, how many milligrams of medicine is remaining in the patient after 24 hours and 72 hours. So let's go ahead and substitute it into this equation right here. Well, we said that 300 times 0.4 to the power of t over 4. So t over 4, well, we know that 24 is our t, so we have 24 over 4, which is just 6. So this means we have 300 times 0.4 to the power of 6. And that gives us a value of 1.2288 approximately. And so we can just round it to 1.23. So that's at 24 hours. Now let's go ahead and do 72 hours, which is the second part of the problem. Well, we know to find our n value, we do t over 4. T is 72. So 72 over 4 equals, 72 over 4 equals 18. 18 is our n value. So we have 300 times 0.4 to the power of 18. And that gives us a value of 0.000021. And then that's our value. So we're just going to leave that as our answer. So those are our two answers for E. So this is 72 hours. Next, let's go ahead and do F. Well, F says how many milligrams of the drug are remaining after t hours or n doses. Our equation is just going to be our answer from D at the end. Duplicate, and we're just going to keep that as our answer, because at any value t, you can use this equation and get your value at any t hour. Another way you could write it, though, is the real form, which is t sigma k equals 0, and then we have 300 times 4/10 to the power of t over 4. That is another way you could write your answer. This is G. The minimum lethal dosage of this pain-reducing drug is 600 milligrams. If the patient is following instructions and continuously or infinitely takes the drug as prescribed 4 hours in between each dose, will the patient ever have this much drug in their body? Now we can use our limits equation that we learned in one of our last videos, and that equation was, alright, so we're going to assume this is finite, because we're going to put in 600 as our final answer. So we're going to have 600 equals, and I'm just going to write this down on the side, the geometric sequence finite formula to find the sum is S subscript n equals A1 times 1 minus r to the power of n over 1 minus r. And to learn how to use this equation, you can watch our video that is in the top right corner in the card. Well, we have 600 as our desired value. 600 equals A1, which is 300, our original value, times 1 minus our r value, which we said is 0.4, to the power of our n. And n is just t over 4. T over 4. Okay, over 1 minus r, 1 minus 0.4. And now we need to solve for t and see at any point can we get a value of 600. Well, we can obviously see that since our amount is decreasing, it's decreasing by 40% each time, or decreasing by 60% each time, and we're only having 40% left. Unless we're having a negative time, the patient will never have this much drug in their body, because you're decreasing and decreasing and decreasing. It doesn't make sense, because if we have 300 and we're going to 120 after 4 hours, we're not going up, we're going down, meaning that we can never have 600. So you can just write for this one, no, because the amount of the drug is decreasing. Okay, now let's go ahead and go to number 2. Well, number 2 says that if a ball is dropped from a 12-foot roof and bounces 2/3 as high on each successive bounce, find the total of number of feet the ball will travel, including all bounces. Well, we assume this is an infinite version, and we know this is geometric, so it's going to converge at some point. So we can say that we have the equation, which is in our last video, s of n, or s subscript n equals a1 over 1 minus r. We know our a1 is 12 because that's what we start at, so we have a1 equals 12 feet, and r is going to be the 2/3 as high, so 2 over 3. That's how much of a ratio we have in between our last and our new bounds. So we have r equals 2 over 3. So we have 12 over 1 minus 2 over 3, which gives us 60 feet. And that is our answer. That's the total number of feet the ball will travel, including all the bounces. Now finally, let's go on to number 3. And number 3 says, a pendulum is released to swing freely. On the first swing, the pendulum travels a distance of 18 inches. On each successive swing, the pendulum travels 90% of the distance of the previous swing. What is the total distance the pendulum swings? And the next question is, after how many swings has the pendulum traveled 80% of its total distance? Well, first, we're going to use the same equation we used in our last problem, which is s subscript n. S subscript n equals a1 over 1 minus r. In this scenario, a1 is 18 inches over 1 minus, and r is 0.9, and that is because it travels 90% of the distance of the previous swing. 1 minus 0.9, and that gives us a value of 180 inches. The last question over here is, after how many swings has the pendulum traveled 80%? So we need 80% of the total distance in our equation at some point. So we have times 0.8, and that gives us a value of 144 inches. Now what we're going to do is we're going to use the equation we used up here, and we're going to use that here. So we have s subscript n equals a1, so a1 is 18 inches times 1 minus our r value 0.9 to the power of n over 1 minus 0.9. Well, we know that s subscript n is 144 because that is the distance we're going to travel. And this is where it's finite, because this is the distance we want to travel. This is what it's asking for. When is it traveled 80% of the total distance? The total distance is 180, and 80% of that is 144. And originally in the problem, to get our total distance, we were infinite because it could go an unknown distance. So we have 18 parentheses 1 minus 0.9 to the power of n over 1 minus 0.9, and this equals to 144. So now we just solve for n, and then we know how many swings it takes for the value. And we get a value of n equals 15.275. And this just rounds to 15.28. The first part of our question asks, what is the total distance the pendulum swings? Well, we calculated the total distance to be 180 inches, so that's our first answer. Our second answer is 15.28, or 15 to 16 swings. This is because the second part of our question asks, after how many swings has the pendulum traveled 80% of its total distance? 80% we found to be 144. The total distance was 180. Multiply that by 0.8. We got 144 as our 80% of the total distance. We substituted that into our finite equation. We got an n value, we solved for n, we got an n value of 15.28, and we said it's either 15.28 or around 15 to 16 swings in order to travel 80% of its total distance. I hope this video helped. If you believe it did, please consider to like and subscribe. I would greatly appreciate it. Again, if you guys have any requests for videos or any preparation tips you guys need, please let me know, and I'll definitely try my best to get a video out. Again, follow us on our Instagram, which is going to be linked in the description below. Like and comment if you enjoyed this video. Thank you.